Now we're going to take a look at question 22 out of 9.3, referring to data set 5 family heights, which contain data from a journal kept by Francis Galton. Use a 0.05 significance level to test the claim that there is no difference in the heights between fathers and their first sons. So they're listing fathers first, that's going to be sample 1. First sons, that's going to be sample 2. And their claim here is that the difference is 0. Well, that's probably our easiest case here. And the opposite of equal to 0, not equal to 0. So we can come over here, put in our labels for null and alternate hypothesis, and then we just go ahead, put the symbols and the numbers from our claim. What goes between them in the null? Equal, because it's always equal. In the alternate, we need the strict inequality, which is the not equal. We put the R, we put the S, and here our claim is represented by the null hypothesis. So I starred the R here. So when it comes time to write the conclusion with respect to the claim, R is going to be talking about rejecting the claim. We may have the evidence to reject the claim. We may not have the evidence to reject the claim. That we'll find out when we get to step E. So the tail of the test, it's a not equal sign. That is a two-tail test, because not equal means either less than or greater than, 2 directions, 2 tails. Our alpha is 0.05. Alpha represents our significance level, and that gives us enough information to write our rule of rejection. Reject the null hypothesis if the p-value is less than or equal to whatever our significance level is. And our test statistic is going to be t, and we want a space for our corresponding p-value, which I will line up directly underneath the one listed in the rule of rejection. So now we're ready to go on over to StatDisk, open up data set 5. And father's heights, that's column 1. First son, that's column 3. So hypothesis testing. And what's telling us that this is a matched pairs case versus an independent samples case is when we're looking at the data, this data in row 1 is all from the same family. The data from row 2 is all from the same family. This 70, which is the height of a father, is paired with the 68, which is the height of the son. So we're going to be looking at differences individually versus this group difference and this group difference, or this group mean versus this group mean, which would be the case if it was an independent case. But since these are paired up individually, we're going to go with the matched pairs. So our alternate here is indeed not equal to 0, significance 0.05. Father in column 1, that's our sample 1, good. Now we need first son, that's column 3. Hit evaluate, hit plot. When we hit plot, we do see that our test statistic is well off in the tail, and in this case, it's the lower tail. So now let's go ahead, take all this information back here. And so our test statistic there is negative 6.347. Our p-value is showing, at least for the first 4 decimal places, up at 0. And that's p-value is not surprising considering our test statistic is more than 6 standard deviations away from what we would expect if there was no difference. So we got quite the difference here, enough of a difference that we are able to reject our null hypothesis, because all zeros is definitely less than 0.05. And when we reject the null hypothesis, that means that we have sufficient evidence to and either the word reject or support is going to go in there, and that is a function of what happens up in our hypothesis statement. Which part of the hypothesis statement represents the claim? It's the null hypothesis. We noted the R. R is for reject. And then the last bit of this is to go ahead and write the claim, which is that there is no difference in heights between fathers and their first sons. So, based on the results, is it fair to say that the first sons are taller, shorter, or likely the same height as the father? Now, when we rejected the null hypothesis, which was that there's no difference, we rejected the idea that they're likely the same height of the father. So that was no, because we rejected no, comma. We rejected the null hypothesis that there's no difference there. So now, are they taller? Are they shorter? Well, that's where we have to take a look to see where we ended up here. And we ended up with the mean difference being less than 0. Well, the way that we were computing the differences is we had the father's height minus the son's height. And we saw that that was less than 0. And that's only going to happen when the fathers are shorter than their sons. So, and we're also seeing this negative, might as well mention it now, in the confidence interval. Our confidence interval is completely negative, and completely negative means whatever sample 1 is got to be smaller than sample 2. So father's height is smaller than son's height there. So based on the result, is it fair to say that the first sons are taller, shorter, or same height? Well, we already ruled out same height. We're saying that fathers are shorter than their sons. We can reverse that by saying the sons are taller than their fathers. So we can cross that out because that's a function of our confidence interval of the population mean difference being negative. So taller. It's fair to say that first sons are taller than their father. And again, this is overall, this is in general. If we went back to the sample data, we would see that individual results do vary, but on average, first sons are taller than their fathers.